Rules for obtaining image formed by concave mirrors. As you have studied earlier, when an object is placed in front of a concave mirror, an image is formed. The image is formed at that point where at least two reflected rays intersect or appear to intersect. Now, to find out the position of an image formed by a concave mirror, we will use only those two rays of light, as you know, which is starting from the object, whose paths after reflection from the mirror are known to us and easy to draw. There are some rules for obtaining images formed by concave mirrors. The Rule 1 is a ray of light AB is parallel to the principal axis of the mirror. It strikes the mirror at the point B here and gets reflected. After reflection, its path changes and passes through the focus and goes in the direction BD. This is the Rule 1. A ray which is parallel to principal axis of a concave mirror passes through its focus after reflection. This is the first law of reflection of the concave mirror from the concave mirror. Now the second one. It should be noted that we have two arrowheads on this AD, the line AD. There are two arrowheads. We have to bear in mind, which are in the opposite directions. The arrow pointing from the left to right indicates the direction of incident ray, and the arrow projecting from the right to left, means DA, is the path of the reflected ray. The ray of light passing through the center of curvature of a mirror is reflected back along the same path because it strikes the concave mirror at an angle 90 degree to the surface, due to which the angle of incidence and angle of reflection being 0 degree. So the ray passing through the center of curvature of a concave mirror is reflected back. That is the second law of reflection. And what about the third law? Third law is a ray of light passing through the focus of a concave mirror. The just reverse of this first one. If a ray of light passing through the focus of a concave mirror becomes parallel to the principal axis after reflection, the ray passing through the focus becomes parallel to the principal axis after reflection. That is the third law of reflection. And what is the fourth one? Fourth one is a ray of light which is incident at the pole of a concave mirror is reflected back, making the same angle with the principal axis. I is equal to R. This is the fourth law of reflection. The ray which is incident at the pole of concave mirror is reflected, making the same angle with the principal axis. Just to recapitulate all these laws. The rules are: the ray which is parallel to the principal axis, of a concave mirror passes through the focus after reflection. This is the first law. And the second law is ray passing through the center of curvature is reflected back along the same path, or it will retrace. The ray passing through the focus becomes parallel to the principal axis after reflection. And when the incident ray hit at the pole of the concave mirror, it is reflected back, making the same angle with the principal axis. Means I is equal to R. Now, the formation of different types of images by a concave mirror. The types of image formed by the concave mirror depends upon the position of the object. The position of the object in front of the mirror. We can place the object at different positions from the concave mirror to get different types of images. They are the object between pole and focus, object at the focus, object between focus and center of curvature, object at the center of curvature, object beyond center of curvature, object at a far off distance, or we can say that is infinity. Now let us study about the case 1, object between the pole and the focus. The pole and the focus. Let us have this figure. To find out the position and the nature of the image starting from A, we draw a ray AD parallel to, this is D, AD parallel to the principal axis. This ray gets reflected at this point and then passes through the focus F. A second ray of light, this one, passing through the center of curvature after it strikes at this point. It will pass through the center of curvature C, and one is which is parallel to the principal axis when get reflected and pass through the focus, and the second one is retracing the same path and passing through the center of curvature. Now the two reflected rays, this one and this one, do not intersect each other on this side or this left side of this mirror. The reflected rays are produced back. If we produce this reflected rays backward, on producing this one, we will get a point where these two rays seems to intersect. That I denote it as A dash, A and A dash, and here it will be B dash when we extend all these points of this object, and we will get A dash, B dash. That will be the image formed. So when an object is placed between the pole and the focus, when an object is placed between the pole and the focus, the image will be formed behind the mirror, as shown in this figure, behind the mirror. It will be virtual and erect, and it will be larger than the object, or we can say it is the image will be magnified. Image will be magnified. So this property is used to magnify the objects. We can use it as a makeup mirror, or we have seen a small mirror in the hands of a dentist. So we can use it as use this property as to magnify the objects, and we can say we can use it as a makeup mirror when we make it close to the face. Dentist mirror. All these are the uses of the object when placed between the pole and the focus. Now the second one. Now consider the object is placed at F or the focus. Object is placed at the focus. Now consider this object which is placed at the focus of this concave mirror. Now the parallel ray of light from the top of the object hits at the concave mirror and passes through the focus of the mirror, giving us the reflected ray. The second ray of light, this one is passing through, hitting on the concave mirror and passes through the center of curvature. It is reflected back along the same path, giving the another reflected ray. Now we can find that these reflected rays are parallel and it will not meet at any point near our eyes. So we can say it will meet at a far off distance, or we can say at infinity. And since the image is formed at infinity, it is not possible to show it in this figure. When an object is placed at the focus of a concave mirror, the image is formed at infinity, as we have discussed, and it will be real and inverted. It will become upside down. It will become real and inverted. It will be highly magnified or enlarged. And what are the uses of this one? If it is hitting at infinity and it will get magnified than the original one, so we can use it as reflectors of the torchlight or searchlight. This is the use of this concave mirror. Now let us consider an object between focus and the center of curvature, like this. Focus and the center of curvature. So when an object is placed at the between the center of curvature and the focus, a ray of light passing parallel to the the axis of this concave mirror, then it will hit at this point and reflect and pass through the focus of this concave mirror. And let us consider another light passing from the A to and hit at this point of the concave mirror, and it will retrace and pass through the center of curvature. And when it intersect at a point A dash here, and when we elongate this figure, or we can extend, we can pass the ray of light from each and every point of this figure, then we will get A dash B dash, which is an inverted one. So the image formed by when an object is kept between the focus and the center of curvature of a concave mirror, then the image is formed beyond the center of curvature. Then we can say the image formed is real and it is inverted. This is upside down now, and it is larger than the object. larger than the object. These are the the properties of the image formed by the object when it is kept between the focus and the center of a curvature. Now, when we consider the object is at the point C, there is a center of curvature. If an object is placed at the center of curvature, the image, what type of an image is formed, we have to see. An image, sorry, then an object AB is placed at the center of curvature. We can see a ray of light which is parallel to the principal axis and it is hitting at D. AD is the incident ray and it will get reflected and through the path DA dash, and it is passing through the focus. As we have studied earlier that a ray of light is passing through the passing parallel to the principal axis, which will reflect and pass through the focus of the concave mirror. Now this is the reflected ray DA dash, and a ray of light which passing from A and it is passing through focus, and it will retrace the path just opposite that to that of the earlier one, and it will hit at E and go parallel to the principal axis. And if a ray of light is passing parallel to the principal axis, hit at this point, and it will go through the focus of this concave mirror. And if a ray of light passing through the focus will go parallel to the principal axis after reflection. Okay, and both rays will intersect at this point A dash, and we can elongate that object or retrace the object and say A dash B dash, and we will get an inverted image of AB at the very same point, which is the center of curvature. This is the image formed at the by the object kept at this center of curvature, and we can see the image is formed is the inverted one of the same object, and it will be of the same length or same size, we can say. So the image formed is at the center of curvature, and it will be real, and it is inverted, the same size as of the object. The image formed is the same size as the object. Now let us consider object is beyond the center of curvature. Object is beyond the center of curvature. Object is beyond. This is the center of curvature. It is beyond the center of curvature. Now, when an object is placed beyond the center of curvature of the mirror, we have to say the ray of light which is passing parallel to the principal axis will hit at this point, and it will reflect and retrace the path passing through F, and this will go and it will come after reflection through the focus. Now another ray of light which is passing through the center of curvature and hitting at this point and retrace the same path, because it is passing through the center of curvature and hitting at the this point of the mirror, and it will retrace the path, and it will go from here to the same point. And we can see both these rays are intersecting at this point, and we can say the image is formed here, and it is between the center of curvature and the focus of the mirror. And it will, as you see, and it will be a diminished one. it is a diminished one, or we can say the small one, and it is inverted as you see, and image is formed between the focus and the center of curvature, and this one is inverted one and it is too small. These are the properties. The image is formed between focus and the center of curvature, and it is a real one, and it is an inverted one, and it is very small than the object. Now consider an object is placed at infinity or a very far off place. If an object is placed at infinity in front of a concave mirror, since the object is very far off, it cannot be shown in this figure, as you know, because the object AB is far off. The two rays which are coming from A, one is hitting at this point and passing through this way, passing through this area, passing through this one, and it is parallel to one another, and it is hitting at this point, which is a pole, and passing through this way, means P to A dash, and one is hitting at this point and coming this way. Now we can see these two parallel lines. One is hitting at this point and retracing this path, and one is hitting at the pole and making the same angles, the incident angle and the reflected angle, and passing through this way, and both these lines hitting at or intersecting at one point, which we are denoting it as A dash, and we can retrace this object A dash B dash, which is an inverted one. So now we can see the image formed when an object is kept at infinity. The image formed is at the focus of the concave mirror, and it will be real, and it is inverted and much smaller than the original object. When an object is placed at the focus of the concave mirror, then the image is formed at infinity, and if an image is placed at infinity, the object is placed at infinity, the image is formed at focus. And if an object is placed at the focus, the image is formed at infinity, and if an object is placed at infinity, the image is formed at the focus. Just reverse of the first one. Now, what are the use of this one? You might have seen the doctor's head mirror and the dish antenna. These are the examples of the concave mirror or the concave surface, and the object placed at infinity. Okay, the concave mirror can be used as the doctor's head mirror and the dish antenna, by which we are receiving the signals from the satellites. Now, the uses of the concave mirrors. We can use it as a shaving mirror, we can use it as a dentist mirror, reflectors of torch as we have discussed earlier, doctor's head mirrors, dish antenna, to focus solar energy. All these are the uses of the concave mirrors. Now, let us consider this example. Focal length of a concave mirror is 10 centimeter. Where should we place an object so as to obtain an image which is real, inverted and the same size? Once again, the focal length of a concave mirror is 10 centimeter. What we have got? What we have got? The focal length f is equal to 10 centimeter. Where should we place an object so as to obtain an image which is real, inverted and also same size? You know that. At the center of curvature, we will get the image which is inverted, real and having the same size of the object only the object is at the center of curvature, and the image is also formed at the center of curvature. Now the f of the mirror is 10 centimeter. The focus is 10 centimeter and the center of curvature is 2 into f, or double of the focal length. So 2f is equal to 2 into 10 centimeter, that is equal to 20 centimeters, and center of curvature is 20 centimeter away from the pole that you know, the center of the reflecting surface of the mirror. So the center of curvature is 20 centimeters. So the image is formed at the center of curvature when the object is placed at the center of curvature, and it will be real and then inverted, and it is having the same size of the object.